principle of conservation of mechanical energy. So it says that the total mechanical energy in an isolated system remains constant. So that is 5.1 state the principle of conservation of mechanical energy in words. And then now moving to 5.2, the question states that use the principle of conservation of mechanical energy to calculate the speed of the box when it reaches point Q. So let's go through our question statement so we can see what is going on. So we have a 2 kg box that is released from rest at point P. As we can clearly see here on the left hand side, it's released 5 meters above the ground, right? We have a height there of 5 meters. It slides down a smooth frictionless curved track PQ, as we can see on the diagram below, right? And then we are looking for the speed of the box at point Q. So we're interested in the speed at this point at Q. So let's jot down the information we have so that we can use the principle of conservation of mechanical energy to determine our answer. So this is at the top, right? When our box is at point P. When it's at point P, we know that VI is equals to 0 meters per second because it's been released from rest. And then we can see the height clearly, that the height is equals to 5 meters. And then now let's go at the bottom, or at point Q, right? So at point Q, the speed there is what we are looking for, right? And then we know fully well that the height is equals to 0 at point Q, right? So the principle of conservation of mechanical energy, it says that EP plus EK at the top is equals to EP plus EK at the bottom, right? So let's go ahead and calculate EP and EK at the top. We know fully well that EP is equals to the mass multiplied by gravity multiplied by the height, you know, for the faint-hearted ones. And then EK is equals to a half mv squared, right? Yeah, I'm just writing that down so that, you know, if you're not already familiar with the topic, you're not confused with what is going on. So EP at the top, we're gonna have the mass, which is 2 kgs, and then multiplied by the gravity, which is 9.8, multiplied by the height, which is 5 meters, and then plus EK. So EK is a half, the mass is 2 kgs, and the velocity at the top is equals to 0 because our object is sliding from rest. And then this will be equals to EP at the bottom. So EP at the bottom, we have the mass 2 kgs multiplied by 9.8 multiplied by 0, right? Because at the bottom the height is equals to 0, and then plus a half, the mass is 2 kgs, and then VF squared, right? We're looking for the velocity or the speed at the bottom, right? So let me go ahead and, you know, solve the left hand side so I can see what we have there. So we have 98 being equals to, and then if I put this here in my calculator, I'm gonna get 0, right? Because, you know, we're multiplying a few numbers by 0, so that should just give us 0. And then if we go ahead and solve this, so we have a half multiplied by 2, right? So that is 1. So we just have VF squared. So now what we're doing, we're essentially taking the square root on both sides, right? And then if you do that, we're gonna get VF is equals to 9.8994 meters per second. 95, not 4, by the way, meters per second. So that's the speed at point Q, right? Using the principle of conservation of mechanical energy. The reason why we're using this equation in 5.2 and why it works is because there's no friction, right? So let's put that in mind, that we can only use this equation when our system is isolated. And then let's move ahead and go to 5.3. So 5.3, we have a statement there saying that the box passes point Q and moves 10 meters on a rough horizontal surface before striking a barrier at point R at a speed of 4 meters per second. And then the question itself is saying that let's use energy principle to calculate the magnitude of the average frictional force acting on the box as it moves from Q to R. Right, so let's jot down all the information we have so that the information can guide us on which formula we need to use, right? Because we just don't pick a formula randomly. We have to be guided by the variables we have. So this speed that we calculated in 5.2, which is the velocity at Q, right? So for our motion from Q to R, that speed is going to be VI, right? Even though from P to Q is VF. So we're going to have VI being equals to 9. So it's basically 9.9, right, meters per second. And then we have VF being equals to 4 meters per second. And then we have delta X being equals to 10 meters, right? And then the last thing, actually the key to the question, is realizing that when the object is moving from Q to R, there's only one force that is doing work on the object, right? So let me show you. The object is here at Q and it's moving towards R, right? Obviously, we're gonna have some normal force there, and we're gonna have some weight, right? And then there's no applied force whatsoever. There's only frictional force, right? So F net in our case is just frictional force, because that is the only force that is acting on our object as it moves from Q to R. So we have also F net, which is equals to the frictional force, right? So with these variables we have, we can use the work energy theorem, right? We can say that work net is equals to the change in EK. We can also use work done by non-conservative forces is equals to the change in EK plus the change in EP, right? All these formulas can work, right? I'm gonna use the first one, you guys can use the second one, and see if we're gonna get to the same answer. I know we are, but convince yourself. So work net, we know that it is equals to F net multiplied by delta X multiplied by cos of theta, and this is equals to a half mvf squared minus a half mvi squared, right? So if we go ahead and substitute, we've already established that F net is just frictional force, right? That is the only force that is doing work on our object. So we're gonna have Fr multiplied by 10 multiplied by cos of 180, right? The angle we use when we with regards to frictional force, it's always going to be 180 because it's opposing the motion parallel to the surface all the time. So yeah, the angle for frictional force is always 180. And then we have a half, the mass is 2 kgs, and then VF, we're given VF, right, 4 meters per second. So we have 4 squared and then minus a half, the mass is 2 kgs, and now VI, we've already established that it's 9.9, right? So we're gonna have 9.9 squared. On the left hand side, we're gonna have minus 10 frictional force, and now all we need to do is just solve the right hand side, and we are essentially done with the equation. So if we solve the right hand side, we're gonna get minus 82.01, and then if we divide that by minus 10 in attempt to find Fr, we're gonna get the frictional force being equals to 8.201 newtons. Right, so that is 5.3. Let's move to 5.4. If there's any questions, there's any ambiguity, you gotta let me know in the comments. So 5.4, the barrier exerts an impulse of 14 newton seconds to the left on the box when the box strikes the barrier. Calculate the change in kinetic energy of the box after striking the barrier, right? So if we need the change, we need some VF and VI, right? So VI is the velocity at which the box strikes the barrier, right? It strikes the barrier at a velocity of 4 meters per second. We have that in 5.3, right? It's right here. So we need VF, the velocity immediately after striking the barrier, right? But then how can we find that? We can find that using the impulse we're given, right? Because we know fully well that the impulse is equals to m VF minus VI, right? The impulse is said to be 14, right? But to the left, let's remember that to the left. So we're gonna substitute that with a negative sign. So we're gonna have minus 14 being equals to the mass of the object, which is 2 kgs. We're looking for VF, and VI is 4 meters per second, right? So we're gonna have minus 14 being equals to 2 VF minus 8. Minus 14 plus 8 will be minus 6, being equals to 2 VF. It is easy to see now that VF is equals to minus 3 meters per second. So that is 3 meters per second to the left, right? So let's go ahead and find the change in kinetic energy. We know fully well that it is going to be equals to a half mvf squared minus a half mvi squared. So we're going to have a half, the mass is 2 kgs, vf is minus 3, right, squared, minus a half, the mass is 2 kgs, and vi is 4 meters per second. And then now it's just a matter of putting that in the calculator. Minus 7 joules, right? Minus 7 joules.